This is your physics paper. Question number 1 is MCQ. Which of the following SI units of
Tesla.
strength? It is Tesla, so that is B. The second one, dash is the device kinetic energy into electrical energy is
Dynamo.
dynamo, correct? Then what is the energy conversion for this? It will be electrical into kinetic for this, and dynamo is what? Kinetic into electrical. Okay, and AC motor you don't have in the syllabus, you have AC generator. So don't confuse AC motor for AC generator. You understanding?
Yes, ma'am.
Okay, so remember, your DC motor works on direct current, correct? But we cannot use this motor directly to our mains. The supply in our homes is alternating current, correct? So we have to have a device which will become AC motor, where we have the rectifier over there. It corrects the DC current into AC and then it works. But this is not in our syllabus. Understanding? So this is not there. What is transformer energy change? Actually, energy change for this they don't ask, because we are going to have electrical into magnetic, no, because magnetic flux, there will be change in magnetic flux and then that converts again into electrical. Okay, so electromagnetic induction. So we come to the third one. Radioactive element forms its own isotope after 3 successful disintegration. The particles emitted are, now its own isotope means if it is XAZ, it is going to be XZ, but this is going to be something else. It will be maybe A minus 4 or whatever. Understood? This is going to remain the same. So if it has 2 beta particles, if 2 beta particles are given out, Z will become Z plus 1 after 1 beta, again plus 1 after 2 beta, and after alpha it will have decreased by 2. So can you see, it will become Z back again. So it will be this. Let us see 3 beta and 1 alpha. No. 3 beta means it will be Z plus 3 and then minus 2. So that is not equal to Z. Understanding what I am saying? 2 alpha, if they are given out, then Z will become Z minus 4 and 1 beta means plus 1. So this again is not equal to Z. Understanding? And gamma radiation, or 3 successive integration gamma radiation. Now gamma radiations, radioactive, they are saying the particles. Now if we say gamma radiations are emitted, remember Z will remain Z, but they have not given this in the choice. Do you know the reason why we cannot take this? Because they say particles, and these are the radiations. Are gamma radiations particles? They are not particle radiations. Understood this part? We come to the fourth. What is the fourth one? Which one is incorrect about beta? The speed is not this. This is of gamma. Number of protons increases by 1 is correct. Number of neutrons increases by 1? No. Protons increases by 1, neutron decreases by 1. They have lesser ionizing power than alpha. Ionizing power than alpha. Beta particles ionizing power is lesser than alpha is true. And what are they saying? Incorrect. So this is true. Now they are saying which one is the incorrect, right? So this is true, this is true, this is wrong. So speed is, this also is wrong, no? 3 into 1 minute. This is 10 to the power कितना है? Is it 10 to the power 8?
Yes, ma'am.
Or is it 5? Because 10 to the power 8 means it is gamma, and the speed wise alpha is less than beta less than gamma. So beta particles will have speed less than 3 into 10 to the power 8, remember, because gamma
Ma'am, it looks like
5.
it looks like 5, no?
Yes.
Okay, so it is, yeah, it is 5. So that's why it is. I read it as 8 and I thought it was correct. Anyway, this is the correct one. This is the correct one. This is the wrong one, and this is the correct one. Okay, so the correct option is B. Which of the following is a source of infrared radiation from here?
hot iron ball.
Correct. Let us come to this. Electrical energy consumed by appliance in certain time is calculated with kilowatt hour expression. Now kilowatt hour expression will be P into T upon 1000. Okay, so this is going to be the expression for energy. Yeah, but they have not given you P into T. So P will be equal to, P into T will be actually VIT upon 1000, or it will be I square RT upon 1000, or it will be V square upon R into T, and that upon 1000. So which one is it? V into I, this is what? I into, this is VIT. This is only VT. This is B. This is the correct one. Correct? Let us come to the next one. Focal length, convex lens. So this is going to be focal length minus 10 centimeter, produces magnification of minus 2. The object should be placed. Now minus 2, never mind the calculations, magnification, your thinking step, magnification is going to be minus 2, but magnification is I upon O. Now I upon O, I is going to be negative because object distance is going to be positive. So if magnification is minus, means the image distance is negative, means it is inverted image. Okay, and 2 means it is inverted and magnified image. So when it is inverted and magnified image, you have to remember object at infinity, the image is at principal focus. If this is 2f and this is f, object beyond 2f, image will be like this. Object at 2f, image will be at 2f, same size. Object is here, the image will be like this, magnified. So we are looking at inverted magnified, means the object is here. So how will you describe it between 2f and f? So 10 and 20.
20 centimeters.
Okay, understood how to think. All of you are understanding how to think. We come to the next one. 6 equivalent resistances 1 ohm each are connected. What is the equivalent resistance between points A and B? Now these are in series and these ones are also in series. So 3 ohm and 3 ohm are in series, 3 ohm and 3 ohm, they are in parallel. So remember, when you have two equal resistors in parallel, the equivalent resistance is half of it. Supposing I have 4 ohms and 4 ohms, the equivalent resistance, if they are in parallel, it will be half of it, means 2 ohm. If it is 10 ohm and 10 ohm, if they are in parallel like this, okay, if they are like this, then the total equivalent resistance will be half of it, like this. Remember, the equal resistors in parallel, it is given by this Rp. If there are two equal resistors, each one 10, then 10 upon 2, like that. Understanding? If there are 10 ohm resistors, there are 4 of them in parallel, then the RP is going to be 5 upon 2 means 2.5. Understood. So how much are we getting here? 2.3 upon 2 means 1.5. Refractive index PQRS. When the light incident from air on these substances are at equal angles, the angle of refraction will be maximum. Now you have the original path and then it is coming from air, so it is going to go into denser one. So you remember that this is the angle of refraction and this is the angle of deviation. If the refractive index is more, the angle of refraction will be less. The deviation will be more if mu is more. So for 2.42, deviation will be maximum and R will be minimum. What are they saying? R should be maximum means I have to look at the minimum. Which one? So which one it is? This one means S. Let us come to the next one. These are mass, linear momentum and kinetic energy. What is the expression connecting the two?
B or B.
Everybody should know this. P square is equal to 2mk. Yeah, everybody knows this. And all of you remember the questions based on this about the sparrow and the crow. Remember the elephant and the mouse. I have told you those questions. You have to remember them. Let us come to time taken by a wave to cover two adjacent crests. Two adjacent crests means it is going to be lambda. Now time taken for one wavelength is going to be one time period. Got it? 12th one. Equal amount of heat is supplied by two liquids P and Q. P shows greater rise in temperature. So delta T for P is greater than delta T for Q. Okay, which means P is going to take less energy and immediately raises temperature by 1 degree C, which means SHC of P is going to be less than SHC of Q.
Option C.
Okay, for this again you could use, if the same amount of heat QP is equal to QQ, then MC delta T of P is equal to MC delta T. You have to be familiar with this. If they are going to have the same SH, if they are talking about the SHC, let us take the same mass, so M and M will get cancelled and C of P upon C of Q will be equal to delta T of Q upon delta T of P. This goes down in the denominator here. Okay, this C goes this side, so CQ becomes in the denominator. Now they're telling you delta T of P is more. That means this is less and this is more, which means this is less and this is more. So SHC of Q is greater than SHC of P. This is, yeah, correct. C is the correct option. 13.
B.
In the Opposite, what does it say? Direction of current is the direction of the flow of, what did you say?
Ma'am, it should be positive charges.
Yeah, it is opposite to the direction of electrons, no? Somebody said B. What it should
Sorry,
be?
ma'am,
Positive
don't have
charge.
anything.
है ना? It is D, it should be. Now, opposite it should be, right? Not in the direction of
Yes, ma'am.
electrons, but opposite to it. Correct, no? So, don't be hasty, okay? Just
Sorry,
check,
ma'am.
rethink your answers. Be careful, okay? Name the ray that
Yes, ma'am.
represents the correct path of ray of light through the glass block in the diagram. Now, here you'll have to use a ruler in order to when they give you a diagram like this. Can you see here? Okay, so D is the original path. Okay, it is going into the glass block, so will it go away from the normal? So not E. Correct? You're with me? Okay, now remember that if it is going through the glass block, the emergent ray should be parallel. So this looks more like a parallel, but this ray doesn't look like parallel. Can you see that? So not this. Not this, because it cannot go undeviated. See here, it's going undeviated, no? D cannot be. So the correct option will be C. What is it? AC. Understood how to think.
Yes,
15th.
ma'am.
15th. Identify the radiation that has maximum ionizing power.
A,
Remember,
infrared.
remember, bigger the particle, more ionizing. So it is A. Now count your marks on 15 and write them down. How many of you got how many wrongs? Now can you see this question? Isn't it the solved question in our textbook? Can you open that textbook? Can you open that textbook? Which page is this on? You found the page number? Did you find the page number? The page number. I want
And
you
there
to.
is no question such like that.
It's a solved question, baby.
No, ma'am.
Why do you say no, man? See here, the first question.
Ma'am,
On
it
page
is not there.
272.
Page 272. How come you said that you can't see it?
Ma'am, the book is not the same one.
Book is not the
Same.
book is not the same. Means
Ma'am, I have the older version.
doesn't matter. Solved question hai na.
Sorry, ma'am.
It's
It
been
doesn't have.
It's always been there. Even if you have the older book, I'm talking about 2015, 2016 also this question used to be there. Okay, only thing is that they have put the mirror image. Okay, now are they giving the same this thing? Are they asking the same questions? What do you observe? Did they say what do you observe?
Yes, ma'am.
Yes, ma'am. Now come on, look at the answers, because see, this is your revision. I can always tell you, but this is your revision also. So if you do not know, read it from the book, because all question is there. What do they say when it is dropped into the coil? What does it say? Found it? Come on, one of you read it fast. Be quicker.
As the magnet enters the coil, a momentary deflection is observed in the galvanometer. So long the magnetic field lines linked with the coil increases. As the magnet completely enters inside the coil, the deflection becomes zero.
Did you understand this part? When it is dropped, when it is dropped, see the magnetic field lines are like this, right? So more and more magnetic field lines will get cut, no, as it comes closer. So magnetic flux increases. When magnetic flux increases, then EMF induced in this coil is going to increase. So it will be momentary deflection, but the moment it goes inside, then no more this thing, magnetic field lines cut, so it will come to zero. So momentary deflection will come. Now state the polarity at A and B. Now if the south comes closer, then A also will develop south polarity, correct? According to which law? Which law it is? The one that says that the polarity is developed so as to oppose the cause. Which law is that?
Lenz's law.
Lenz's law. Very good. So question number 2A, first part, right over there, page 272. Okay. The second part, A will have.
Excuse me, ma'am.
Hmm.
Ma'am, but if we use the clock rule, then it's coming as north.
You don't use clock rule. Clock rule is when the current flows the polarity. The current is not flowing over here.
Yes, ma'am.
The current is induced over here.
Oh, yes, ma'am.
Understanding? So you can't use clock rule here. When is clock rule to be used? When the current is going like this, then this
Yes,
is going to give you the south polarity, the coil, the face of the coil facing you. But the current has to pass through that. Here the current is
Yes,
not
ma'am.
being passed, no, current is induced, no, because of the magnetic flux being changing.
Yes, ma'am.
Okay, so remember
ma'am.
that. Okay, so
Thank
A
you, ma'am.
is so be careful. Good, you are asking the questions. So all the doubts from your brain will go. B will be which one? If this is south, this will be
North.
Don't write only S and don't write only this. Like that, don't write N and S. Name the direction of the current in the coil. Now, current in the coil is going to be from direction of the current in the coil. So now tell me, if it is south from here, so this will be clockwise current now. Now you understood? Hello?
Yes, ma'am.
Okay, this is south. So if you look at it from this side, it should look like this. So you'll have to rotate the page by 90 degrees. Okay, so it will be like this. So it will be from A to B, no? Correct? It will be going this way, this way, this way, coming out like this. Understanding? So it will be from A to B. So right away the third part. What is the third part? A to B. Okay. Now if it is going like this, the deflection will be where? It will be this side. Understanding? Understanding. If they tell you copy the diagram and show the deflection, because the current is going this way, the deflection will show this direction. Okay. Name and state the law used to determine the direction of the induced current. Direction of the induced current was after the south polarity we said the direction, then it was the which one? Clock rule. Understanding?
Yes, ma'am.
Okay. What will you observe? What will be the observation? If the coil has twice as many turns. Twice as many turns, then turns will be, deflection will be twice as much. Understanding? Because the induced EMF will be doubled. So will you write the fifth one? The deflection doubles. Draw the label diagram of electric motor obtaining clockwise direction. Now they have given you this for 3 marks, so you can But I think for you it is cancelled, no? The diagram of motor,
Yes, ma'am.
it is
Ma'am, I
cancelled,
had a
no?
doubt in earlier question.
Huh.
Ma'am, they asked us about the direction of induced current. So we said the answer is clock rule. Instead, it is Fleming's right hand rule.
Where is Fleming's right hand rule?
Ma'am, the fourth question,
No,
the direction of.
Fleming's right hand rule is for the straight conductor, and for closed coil it is Lenz's law. Straight conductor, if I have north here and if you have south over here, okay, and then I have this, and then I move this, let us say, out of the plane of the paper. Okay, so if I am
Yes, ma'am.
showing it as out of the plane of the paper, then I will say that the direction of the induced current, this is your A and this is your B. I move it into the plane of the paper or out of the plane of the paper. Then the induced EMF, that is Fleming's left hand rule.
Yes,
What
ma'am.
are they saying? Direction of the induced current. But here actually what is happening, Lenz's law is giving induced, Lenz's law tells you the polarity. What is Lenz's law telling us over here? Polarity acquired here. But the direction of the current, because this is south, so it is going to be clock rule. Did you understand?
Yes, ma'am.
Okay.
Yes, ma'am. Thank you.
State the principle on which it works. The principle of electric motor, learn it up quickly. Okay, that's your homework. Will you learn it? State 2 ways to increase the speed of the motor. What are the 2 ways to increase the speed of the motor?
By increasing the current
Increasing the
and by
current.
increasing the number of turns in the coil.
Increasing number of turns in the coil. Very good. Identify the electrical components given below A, B and C. Now remember I told you live on the left in the plug, correct or no?
Yes, ma'am.
So this is a socket. So live will be not on the left, it will be on the right. So
Yes,
B is
ma'am.
going to be your live, A is going to be neutral.
Earth. C will be earth.
Yeah. How's it so far? Good, bad or ugly?
Good, ma'am.
Hmm. Now this is the soft iron core PQ. Show the windings on the soft iron core with an external circuit so that north polarity is created at Q, means you have to make this as an electromagnet. You're with me? So quickly show this. Tell me when you're done. Show that rectangle. Tell me when you're done. You're with me?
Yes, ma'am.
Now they are saying that make this Q as north. So you will have to show the external circuit from here to here, and the external circuit will be the key and the cell. Now the cell, I'm not showing the positive or negative, and I'm going to show the rheostat like so. Okay, this is the external circuit and the cell is going to be here, and I'm just going to show both of them as the same height. I don't know which is positive and which is negative. Now I want north here, so I must first draw the windings the way I'm comfortable with. So if let us say I am comfortable with this, okay, so I will not draw too many lines. Did you see what I've done? You saw what I've done? Now if this is not, then from here if you look, it should be anti-clockwise. Now from here, this way will be clockwise and this way will be anti-clockwise. Are you with me? Hello?
Yes, ma'am.
Yes, ma'am.
Understood, right? So now you are going to show the arrow this way. So that will make it anti-clockwise when I look from here. So it will go this way, which means it has to be this way, the current. Understanding? Did you understand this? So the big line, that means the positive I should show here and the negative I should show here. Did you understand what we have done? Everybody understood?
Yes, ma'am.
Okay. Now they say show the magnetic lines of forces. Now magnetic lines of forces, when they give you a soft iron core like this, it becomes a little difficult. So ideally what you should do is you should have a little fatter, okay, little fatter core. So you will show this way. This is the axis, this is your north, so north to south. Then you will show from here like this, you will show one like this and show it this way, north to south, and then show this way and show it north to south. Then you can just show one more like this and let it go this way. So the magnetic field lines are being seen like this. Make sure that these lines don't touch each other, don't cut each other. If they cut each other or touch each other, you will get a straight zero. Inside you will have to show this arrow this way and this way, because inside the magnet it will be from south to north, the magnetic field lines. Are you with me so far? Hello. Now some of you who draw the magnetic field lines, you show it like this should never be like this. Don't show it like a semicircle. How it should be? Like a butterfly. I told you like this. Okay, it should be like a butterfly. You understanding what I'm saying?
Yes, ma'am.
Okay. Now complete the following. Write this 88R2226. No, it is. It's 5 or 6?
Yes, ma'am. 6.
6 it is, right? Okay. So the alpha particle has gone. So it is going to become what? It is
222 and 86.
2, 2, 2, and this will be 88 minus 2 means 86. Okay. Now I do not know 86, so I'm just going to put over here x. Yeah, and then I will have
Helium.
no, 1 minute, what are they saying? Alpha plus helium 4 2, and then it loses beta particle, so it will become x 2 2 2, but here it will become 87 000. So if I call this as x1, I'll call this as x2. Don't let both of them be x and x only, because 87 and 86 are different elements, no? Understanding?
Yes, ma'am.
And you're not expected to know these elements, okay? So normally they will give you, if they are telling you if it's polonium or whatever, they'll give you the symbol, but you are not expected to know that. Now what are they telling you? This is A. With beta particle it has become this. So what is this now? This
It will become
is
250 and
gamma. So I'll write here gamma, and I will write over here x, and 2 beta. 2 beta particles means this has become z plus 2. So this
yes,
will
ma'am.
be 118. Okay, but the mass number 250 will not change. Okay, and gamma means this is the same 118 here, 250 here, but we will put the excited state. Okay, when it's in excited state, it is going to lose gamma. Here, what will you write? 2,
0.
2, 0.
2 into bracket 0 minus 1
Yes,
beta.
ma'am.
Huh. Okay. What's a beta particle? This is a learning step. Show with the diagram the configuration of an alpha particle. How will you show the diagram alpha particle? This will be helium and it will have 2 protons and 2 neutrons.
2 neutrons.
Will it have electron? No. Okay, so you will have to show like this. Understood? Radioactive substance R is kept in the magnetic field. Show and draw a label diagram to show the Becquerel rays. What is the magnetic field? It is into the plane of the paper, no? When it is crossed like this, it is into the plane of the paper or out of the plane of the paper. Ma'am, we are confused. Go look in the book, confirm there is radioactivity.
H305.
What does it say? Is it into or out of? Into the plane of the paper, right?
Yes, ma'am.
Yes, ma'am.
Okay. Oh. 305, no? You said?
Yes, ma'am.
Ma'am.
Uh,
Uh,
7th line.
Normal to the plane of the paper and inwards, correct?
Yes,
Seventh
ma'am.
line, double underline that inwards. So remember, this means it is inwards. Make a note of it. If the magnetic field is shown this way, this is mag field outwards. Okay, and make a note of it. If it is this, then it will be mag field inwards. Everybody knows how to proceed for this. Is there anyone who gets confused for this?
No, ma'am.
Who gets confused? What will this be? Gamma, correct? Now, for the deflection, which rule do we use? See, nobody knows about it. You say we don't get confused, but you don't tell me. Which rule do we use? Say, I don't know.
Fleming's left-hand rule.
Very good. So Fleming's left-hand rule. So we will make sure that the magnetic field is inwards. Okay. And if you do that with the normal position, the center finger is pointing downwards. Correct? And the thumb is going on the right side. So on the right, which radiation will we show? Alpha or beta?
Alpha. Or beta.
Now remember, the current is going downwards, which means the electrons are moving upwards. So very good, you will show this way and show the deflection like so. Okay, and when it is alpha particles, you will show this way. Understood? That's the time you have to rotate the wrist. Keep your finger, which one? The forefinger, into the plane of the paper, and turn your center finger in the direction of alpha, and thumb has gone on the left. So this is your alpha. Now when you are showing this visibly, this should be making more angle than this. Understanding? And when you show this diagram, can you see what is this label?
Lead lined box.
Lead lined box, no. Lead lined apron, lead lined gloves. But the box has to be only lead, not lead lined.
Lead box.
Okay, it is lead box. Understanding? Not lead line.
Yes,
What
Yes,
is
ma'am.
this?
radioactive substance.
Radioactive substance. And where you write like this, on the side write alpha, beta and gamma and spell it out over here. So that alpha radiation. Understanding? So that you'll get your full 3 marks. Understanding? You spell it out here, spell it out here. Okay? Just teaching you how to avoid wasting our marks. Isotope of radioactive element represented by this. Find the number. This you can do on your own. Very simple. Yes. Let us come to question number 4. Name the type of wiring in the household circuit is which one? Which one it is?
Staircase wiring.
Ring system. Ring system. Hello. There are two, ring system and tree. The wiring system is the ring system. Okay. A is the ring system, and state the advantages. So the advantages of ring system are given over there. Name the device used to protect the electric circuit from overloading. So what is the device? It is the fuse. Correct?
Or MCU.
Then the second one, on which effect of electricity does this thing work? On the heating effect. Heating effect of electric current. What is it? H proportional to I square RT.
RT.
Define resistivity. You can do that on your own. Unit on your own. How does it depend upon the dimensions of the conductor? It does not depend upon dimensions, because resistivity of what? Unit length and unit area of cross section. So it does not depend on dimensions. Okay, let us move to this one. How is this one? 6 volt this. The circuit is switched on. The ammeter reads 0.5. So this is I in the circuit is 0.5. Calculate the value of unknown resistor. So what do we have? Rs is going to be R plus 3. Put bracket and write ohm. Correct? Then for the first part, we are going to say I is equal to V upon R. So 0.5 is equal to 6 volt upon R plus 3. Understanding? So R plus 3 is equal to, don't sit and multiply by 0.5, okay? It will be pathetic. Just put the whole thing over there, and 6 into 10 upon 5. Did you see what I did? Don't put 0.5 and don't say 0.5 divides like that, okay? Understood how to proceed? So R will be equal to 12 minus 3, which is how much? 9 ohm. Understanding how to proceed? The charge passing through 3 ohm in 120 seconds. So for the second one, they are saying charge means Q in 3 ohm in 120 seconds. Now I know that I in 3 ohm is going to be 0.5 ampere, correct? Hello. Now I know that I is equal to Q upon T is equal to 0.5 ampere. So Q is equal to 0.5 multiplied by T means 0.5 into 120 seconds. Understanding? So that is 5 into 12 means how much? 60
60
coulombs.
coulombs.
Understanding? The power dissipated
R square R.
very good, dissipated is going to be equal to I square R. So I is 5 upon 10 into 5 upon 10 into R is 3. Is it doable? 25 375, so 0.75 watt. Understanding? State the voltage. This is learning type of question from household electricity. What is this? Prism deviated through angle delta when it is incident. Draw the label diagram to show the variation of delta with I. Now, variation of delta with I is going to be a little confusing for some of you. Let us look at the diagram that we need to draw. So you will show.
Ma'am, it is prism.
1 minute, what did I say? Not the glass slab.
No, ma'am.
Oh, sorry, I made a mistake. Draw the label diagram. The graph, you know this one. You know the graph is like this. Make sure that it is not this way and this way. If the curve goes inwards, you'll get a straight zero. Okay, it has to be what type of curve? Open curve. What type of curve? Open curve. Okay, remember that. So that is doable. Concave mirror and convex lens are held in water. Changes in their focal length increases. Why don't why do they put concave mirror also? Why do they put convex lens? We know concave mirror. Now concave mirror, if we keep, does it follow the same thing? This is what happens, no? The ray coming from infinity. Hello?
Yes, ma'am.
Now concave mirror is kept in the water. So this full thing is in the water. So will this focal length change?
No, ma'am.
So mirror, nothing will happen, but convex lens, focal length increases.
Increases.
Okay? Okay, now what is this person saying? Ranbir. This ICC question. The image was twice in the concave lens. Now concave lens always gives what? Diminished image, and it is upright and it's virtual, correct? So how can you get twice the size of the object? Can the image which is diminished means twice the size? इसके पास
No,
ब्रेन
ma'am.
है क्या नहीं?
Twice the distance.
Ma'am, he is not correct.
Maybe twice
Yeah, he is made. Is he correct? He is not correct. And what is the reason? Since concave lens always produces diminished image, so it cannot be twice the size of the object. Okay. Now this one, when they give you the diagram like this, you please don't draw the perpendicular like this. Huh? You draw the perpendicular properly perpendicular. Okay. I have told you how to make this perpendicular. Can you see they put slanting and they put 90 degrees here? Everybody knows what's going to happen over here. Hello? So you will have a normal here. Let us see what else is going to happen. This is going to be 30 degrees. This is 90 degrees. This will be 60 degrees. This will be 30 degrees. And what you will write over here for 30 degrees, angle I is less than critical angle, therefore refraction. There will be no TIR. So where it will go, show arrow, arrow. And it should have gone like this, but it will go away from the normal because denser to rarer. Show visibly greater. And what will you say? Angle of refraction is greater than 30 degrees. Understood? For 2 marks. Understood? Name the
Yes.
electromagnetic radiation used in war signals is infrared,
Infrared.
and you know the reason. This is learning type. Uranium 238 is oxidized. Nothing will happen to the radioactivity. Why? Because radioactivity is a nuclear phenomenon and oxidation is chemical change. Chemical change does not affect the nucleus. Okay, that's how you will mention. Are you with me? Can I move faster? Phenomenon taking place on the sun is nuclear fission or fusion. Write the reaction showing this fusion. Background learning type. One example of the different types of background radiations, internal and also na one example. Safety precautions while handling radioactive substance. What will you do? Wear lead lined apron, lead lined gloves,
Mask.
and use long handled lead tongs to handle. Okay, don't use the film badge and all that, too much you will have to write. Two differences between forced and resonant vibration learning type. Write it in columns. Piece of ice of mass dropped in 20 grams of water. Calculate the final temperature. Now some of you may make a mistake for this. Let us quickly solve this. You have the ice and there is water. So our first column is substance, mass, then we have SHC slash SLHF, and then you'll have T1, you'll have T2, and then you'll have delta T. So 40 grams of ice and 200 grams of water. Initial temperature is 50 degrees C. Calculate this, and it is melting ice, so this will be 0 degrees C. Specific latent heat of fusion right over there, LF is 336 into 10 to the power 3 joule per kg. And calculate. Okay, so now for water they have not given you SHC, so that will be 4200 joule per kg per Kelvin. All right, this is melting ice, so you have to show the schematic diagram. Ice at 0 becomes, quickly show this, becomes water at 0 degrees, and that becomes water at x degrees C. Call this as Q1, call this as Q2. What formula over here? MLF. Why? Because change of state. Which formula here? MC delta T. Why? Because change of temperature. So here delta T is X, and here it will be, remember the ice is going to cool the water, so 50 minus X. Okay, then what you will say? By the principle of calorimetry, at equilibrium we will have heat gained by ice is equal to heat lost by
Water.
So we will have MLF plus MC delta T is equal to M1 C1 delta T1. So I prefer to do this M into bracket LF plus C delta T is equal to 200 into, now this is 4200. So shall I make the mass into kgs?
Yes, ma'am.
So this will be 2000 divided. So this will be kg into C is 4200 joule per kg per Kelvin into delta T is 50 minus X. Okay, I have 1, 2, 3 zeros getting cancelled. Here it will be 40 upon 1000 into 336 into 10 to the power 3 plus C is water, 4200 into delta T is X, and that is here 20 into 42 into 50 minus X. Four upon 100 into no 336,000 plus 4200x is equal to 100 upon 4 into 20 into 42 into 50 minus x. 4 ones and 4 fives. So 21 221,000 into 50 minus x. Okay. So 336,000 is sorry. Plus 4200x is equal to 21 into 5 is 105, and there are 4 zeros, minus 21,000x. I should have kept this in grams only rather than kg. Such a headache this is. What should I do? Is this divisible by 21? 21 once 21.
Yes, ma'am.
So 21
16 times.
16 times it's going, no? It's such a headache. So you have 4200 plus 21,000. So 21,000. So you are getting 25200x. Okay, and that is equal to this minus 336,000. So what am I getting here? 10 minus 6 is 4.
714
14.
000.
This is and 7, no? So x is equal to 714,000. I normally don't convert into kg. 252, 1 2, there are two zeros, no? uh, 7 should go here. 7 threes 21, 7 6 42, 7 1 7 0, 7 twos 7 zeros. Now what will I divide by?
6 times 6.
6 times you want to go? Okay. 6 ones 6, remain 4.
170.
6 sevens. But what a pathetic calculation this is. 2 goes 3 times and 2 goes 85 times. So what is the temperature? Oh dear me. What am I getting? X equal to 85 upon 3. This is 3 to 6, 3 8 24. Okay, this is the final temperature. Okay, how is it? Good, bad, or ugly?
Good.
Surprised to see the water boiling at 115 in the container. What could be the reason?
High
The
pressure.
addition. No, why pressure? It's in a container, not in pressure cooker. So obviously there's some
Impurity.
impurity, means salt or sugar or some salt has been added. Maybe potassium nitrate something. I don't know whether she is in the laboratory or where. Understood, no? Because addition of impurities raises the boiling point. Why the drinks are cooled better? This is learning type of question. I have taught you how to write this. What is this? State the melting and boiling point. This is a solid, so this is melting. Melting point is T1, boiling point is T2. Name and define the term represented by portion BC. This is going to be the melting, correct or no? So you have to define that. Understanding why is the portion BC shorter than DE? BC is loosening the bonds and this one is breaking off the bonds. So the heat required for BC is much lesser than the heat required to break off the bonds. Okay, understanding. Now here the teacher has expected to write specific latent heat of vaporization. This is specific latent heat of, but the thing is that if this is energy, then this becomes latent heat. If it is time, it's not because of that. So you could actually say that the heat taken for melting means latent heat, not specific, but latent heat of fusion is only to loosen the bonds. So it is much lesser than the heat required for what? Breaking of the bond, means the latent heat of vaporization. Okay. The hammer of mass 2 kg is raised to the height of 3 meter and dropped on the nail. If the hammer hits the nail with the force of this, calculate the distance to which the nail penetrates the target. Now some of you will say you don't like it. So let us look at your question number 8a. The mass of the hammer is 2 kg. Okay, and it is raised to, so the height of hammer is equal to 3 meter. Okay, it is having potential energy. You're with me? So potential energy of hammer will be equal to mgh. Agreed? How much is mgh? 2 into 10 into h is 3. So that will be 60 joules. You're with me? Hello. If the hammer hits the nail with a force of 1000 Newton, so force of hammer is equal to 1000 Newton, yeah, and it is uh, force of the hammer, and you have to find the distance uh, of penetration of a nail, which we'll call as S is equal to question mark. Now remember that the work done
Fs.
by hammer will be equal to the potential energy of hammer. Understanding? And right over there by law of
Conservation of energy.
conservation of energy. So work done is going to be F into S is equal to mgh. So 1000 into S is equal to 60 joule. So S will be equal to 60 upon 1000, those many meters, 0.06 meter. That means 6 centimeter, but you keep it in SI unit. Okay, right over there, the distance of the nail. Understanding the principle of transformer, learn it, electromagnetic induction. One advantage of alternating current, this is learning type. State the function of split ring in DC motor. They are going to, what do? Every 180 degrees, what do? They change they reverse the direction of the current so that the rotation of motor will be in one direction only. These are all learning type of question. What is this? Show that the mechanical advantage of a single fixed pulley can be, how can the mechanical advantage of single fixed pulley be increased? How can we increase this? By lubrication, correct? Because there is movable pulley, then you can say decrease the weight of the lower block or the movable block. But if it's a fixed pulley, then the only thing you have in hand is lubrication should actually lessen the force of friction. Understanding?
But how will we show it in diagram?
How will we show it? Draw the label diagram to show it, no? This is how the single fixed pulley is, right? This
Yes, ma'am.
This is your load, and this is the effort. Rigid support, single fixed pulley. These are this thing. It is for 2 marks. the rope should be perfectly elastic, and then I think you have to just show this. You can't show lubricating it here, there.
Ma'am, can we point at the surface of the rim and we'll show
between
lubricating surface? Yes, ma'am. There. We'll show lubricated surface.
apply lubrication at these, like that we can say, no, at the this thing, the bearings and between the surface.
Yes,
uh,
ma'am.
no, only here. I don't think here will. If you lubricate this, no, this is not going to move. Little bit of friction is required, otherwise it will, this will, the rope will turn, the rope, the pulley will turn, but the rope will not turn only if there is too much lubrication here.
Yes, ma'am.
You understood? Okay, so only at the pulley bearing. What is explain why the intensity of sound emitted by the increase when it is mounted on the board. All these are learning questions. Remember, the soundboard that is there, it contains the air. Large volume of air is sent into vibration. Understanding that increases the intensity, and also the board is so constructed that the frequency of it is equal to the frequency of the wire, so due to resonant
Yes, ma'am.
vibrations, so both you will have to mention here. Man standing in front of the wall hears the echo after 3 seconds. He walks X meters away and produces the same sound. He hears it after 5.25 seconds. Calculate the distance walked away from the wall. Is there anyone who gets confused for this? Please
No, ma'am.
show the two cases. Don't do T2 minus T1 and all that. Don't do like that. Okay? First you'll take D1, then you'll take D2. Define the couple. Two forces bring the object into rotational motion with a moment. This calculate the distance. Moment is equal to the force into perpendicular distance. Correct or no?
Yes, ma'am.
So only thing is that this kgf that is there, you'll have to make it into Newton. Understood? Don't use kgf. So what you'll say, the force is 0.7 into 10 means 7 Newton.
Yes,
Understanding? Okay,
yes, ma'am.
and then write the formula and then substitute. The ray produced from electric spark causes fluorescence. Now electric spark causing fluorescence is which one? Which radiation is produced by electric spark? Is it X-ray? It is ultraviolet. Come on, turn the pages quickly. Give one use of the radiation. How should the appliance be connected in the household wiring system in parallel? Give two reasons why they should be in parallel. So there is a lot of work which is learning work in this. Very few application except for this calculation was bad. Okay, otherwise it was a relatively simple paper and we stopped there for physics.